Hi guys, welcome to Structify. Today we will talk about minimum spanning tree. Okay. Now before minimum spanning tree. Now before we talk about the minimum spanning tree, we should know what is a spanning tree is. Okay. Now by definition, a spanning tree is a tree in which we have n nodes, that is all the nodes present in the original graph, and n minus 1 edges, and all the nodes are reachable from each other, which means this is the definition. But if you want to simplify it, if we say we have n nodes, right, this is a graph, we have n nodes, the number of edges would be n minus 1. This is important. Okay. Now let us understand this by an example. Okay. So let us draw a graph. Say this is the 0 node, and this is an undirected graph which I am drawing. 1 node, 2 node, 3 node, 4 node. We connect this and we connect this. Okay. So the edge weights, let's place them 2, 3, 7, 5, 8 and 6. Okay. So this is the graph that we have. Has 5 nodes, which is n, and 6 edges, right. So we can say that E, which means in order to convert this into a spanning tree, we need, for spanning tree, we need n minus 1 edges. So E new for this spanning tree should be n minus 1, where n is equal to 5 minus 1. So E new should be equal to 4. Now this is very important, keep this in mind. Okay. Now how do we convert this into a spanning tree? Now this one way we can do it is by, say we have this, we have this, we have this, we have 3 and 4, right. So what we can do, so check this out, 2, 3, 8 and 5. How many edges are there? 1, 2, 3 and 4, 4 edges, right, which is there, and the nodes are obviously 5 nodes, right. This is a spanning tree. Now one thing which is we must understand is that a graph can have multiple spanning trees. Another example could be 0, then 3, then 1, then 2 and then 4, and obviously 6, 8, 3 and 7, right. And there can be other spanning trees as well. Now out of all these spanning trees, what we are interested in is the minimum spanning tree, right. Minimum spanning tree is a special case of all the spanning trees that can be formed out of this graph, okay. Now what is the definition of a minimum spanning tree? The formal definition of a minimum spanning tree is one of which the sum of all the edge weights is minimum, which means that if we have a set of edge weights, say E1, E2, E3, E4, E, say number of edges is EE, and we have number of nodes, say N1, N2, N3 dot Nn, that we have the number of nodes. So for a spanning tree, the number of edges would reduce to E1 dot dot to En minus 1, right. Now, for the spanning tree, this E to n minus 1, the sum of E to n minus 1 would always be minimum. So, consider this minimum spanning tree to be an optimization on the type of graph that can be formed. The spanning trees can be found from the original graph, right. It is an optimization. Now, again let us draw the graph again, right. So, we have, this is the original graph, this is 1, this is 2, this is 3, this is 4, and we have 7, we have 5, and we have 3, we have 6, we have 8, and we have 2. This is the original graph, right. Now, in order to figure out a spanning tree, right, which should also be minimum, we can say that the graph can be this 0. Let us draw the nodes first, because we need all the nodes. It is the edges that we can play with, right. Say, like if we say 2 and 3 and 6 and 5, this is the minimum spanning tree, right. So, if spanning tree is the superset, minimum spanning tree is the subset, right. We keep in mind like that. So, there are a few algorithms from which we can figure out the minimum spanning tree. The first one is the Prim's algorithm. And the second one is the Kruskal's algorithm. So, you might ask that why do we need a minimum spanning tree? I mean, like, what is the utilization of a minimum spanning tree, right? Well, the utilization of a minimum spanning tree beyond leet code, beyond competitive programming in the real world, is that whenever we want to minimize the cost, hence sum of edge weights is minimum, right. Also, we simplify the graphs, right. Hence no cycle and no redundant paths, right. So, this can be used in like, I don't know, computer networks. You can use it in computer networks, right, for connecting servers with minimum cables, or you can use it in to find the least costly way to connect cities with roads. So, that's about it, all about the minimum spanning tree. And if you have any questions, you can just drop them in the comments, and like, share, subscribe. Thank you.